Okay, the distance formula. All right, in this video lecture, our objective is we want to use the distance formula to find the distance between 2 points. All right, let's start off with reviewing something we already know that's going to be applicable in this lesson. Okay, we know the Pythagorean Theorem. We've seen the Pythagorean Theorem probably since either pre-algebra or algebra. Certainly by the time algebra came around, we've seen the Pythagorean Theorem. So the Pythagorean Theorem states that given a right triangle, okay, so here's a right triangle. A right triangle is made up of 3 sides, but when we talk about a right triangle, 2 of the sides we call the legs, and the side opposite the right angle we call the hypotenuse. So given a right triangle, the Pythagorean theorem tells us that the square of one of the legs plus the square of the second leg is equal to the square of the hypotenuse. In other words, if we draw a square using this leg's length as the side length, and we add it to the square that uses this leg's length as the side length, these 2 squares, when added together, create the same area as the square that has a side length of this hypotenuse, which obviously is the larger square because the hypotenuse is the longer side. So we know leg squared plus leg squared equals hypotenuse squared. Perhaps one of the most popular theorems in all of mathematics. Now, I'm just going to rewrite this, and I'm just going to switch this up and say the hypotenuse squared is equal to leg squared plus leg squared. Same thing, I just switched what was on each side of the equal sign, left and right. Now, we know with an equation, if we do the same thing to both sides, we don't change the fact it's an equation. So I'm going to square root both sides, okay, because this is the hypotenuse squared. I'm going to undo the squaring using the inverse operation square rooting, and I'll do it to both sides. And I come out with the hypotenuse, okay, so the length of the hypotenuse is equal to the square root of the leg squared plus the leg squared. Okay, we're going to make use of that in this video. Okay, so let us find the distance between the points 1, 3, and 5, 6. So we're going to simply use the Pythagorean theorem. So 1, 3. So I drew the first quadrant, and I've counted by 1s, although I've labeled by 2s. The point 1, 3, here's 1, I'll go up to 3. And here's the point 1, 3. And the point 5, 6. Here's 5, let's go up to 6. I'll put it approximately here. And here is the point 5, 6. And I'll connect these 2 points because I want to know their distance. I'll call that D. D for distance. Okay, so how far is it from here to here? Okay, well, the way this is done, that's easiest to do, is to draw a right triangle. Okay, so I tend to always have a base, a horizontal base. Okay, and then I'll have a vertical like that. So, but I always have a horizontal, the lower horizontal, if I may. You'll see that in my next example. So I'm drawing a right triangle, and I'll put a right angle to indicate that. Okay? Because as soon as I have a right triangle, I know the Pythagorean theorem is applicable. Okay? So I'll put a point right here. Okay? So I know the hypotenuse, which we're calling D, hypotenuse, which is the distance, D in this triangle, is equal to the square root of the leg squared plus the leg squared. Okay, so D is equal to the square root. Okay, well, we now can simply count. This is a leg right here, and it goes from 1 to 5. So from 1 to 5 is a distance of 4. So 4 squared. This is the second leg, and this one goes from 3 to 6. So its distance is 3. So I've replaced the leg length with the one leg length, in this case the horizontal leg's length, with the fact that it's 4 units long. And the vertical leg, in this case, is 3 units long. and now it's just a math problem. So the distance is equal to the square root. Well, 4 squared is 16. 3 squared is 9. So the distance is equal to, well, the square root. 16 plus 9 is 25. And so the distance is equal to the positive square root of 25 is 5. Of course, we're positive because we're talking about distance. So the distance between these points is 5 using the Pythagorean theorem. Okay? Now, I counted, so I went from 1 to 5, 1, 2, 3, 4, 5, to get the fact that this leg's distance was 4, or its length was 4. But another way I could have done that is I could mark this. This is the point 5, 3, I believe, right? Yes. Okay. And I could say, well, wait a second. If this is 1, 3 and this is 5, 3, this is the horizontal distance. So I'm looking at the x coordinates. It's 5 minus 1. And I came up with 4. And I can do the same thing here in the y direction. Okay, I'm looking at the y coordinates to find the change in the y direction. Well, it went from 6 to 3, or 3 to 6, either way, but 6 minus 3 gave me 3. So I could do subtraction as well, as opposed to just counting. In either case, I get the distance from one point to the other. Okay, so let's put this together in a general formula so you can see it. Now, I'm kind of a fan of using this idea in counting, but sometimes you can't always count. It's not the fastest way. So let's take a look at a generic example. Okay, I think you can see my paper. All right, so we're going to find the distance between any 2 points. We're going to call them P1 and P2. Okay, so I'll draw a graph here, and this time I'm going to include quadrants. Whoops, let me turn my book page. I'm going to include quadrants 1 and 2. So I'll draw a line like this, and I'll kind of put it like that. So here's my x-axis, and here's my y-axis, and I'll put a point here, and this will be the point P1, okay? And P1 has coordinates x1, comma y1. We don't know what they are. Now we know the x is negative in this case. We know the y is positive in this case, but we're going to generically say that this is x1 and this is y1. And we'll put point P2 down here, and we'll say that the coordinates, oops, I forgot the 2. We'll say the coordinates for the point P2 are equal to the x is x2 and the y is y2. Okay, and so I'm going to draw a line between these two. Hopefully I get it reasonably straight. And that's D. What is the distance between those 2 points? Okay, well, same idea applies. I'm going to draw a triangle, a right triangle, because I'm going to use the Pythagorean theorem. Okay, and I'll put a point here. Now, this point, this point has the same x as this. The x here, which is x1, is for this point and this point. And this point has the same y as this point. As you go across, the y value is the same. So this point happens to be x1, comma y2. Okay, so the distance is equal to the square root of leg squared plus leg squared, just like we did before. Only this time here we're going to have to do some subtraction with these variables instead. I'll skip a line just so we have it's a bit more legible. Okay, how do I find the distance from, let's see here, okay, the distance in the x direction? Okay, we'll have to start at x2. I need to subtract x1. The distance from here to here is the difference between them. Just like we saw in the previous example, the distance is the difference between them. So this leg's distance right here is x2 minus x1. This distance across here. So I'll use x2 minus x1, and of course that length of that leg is squared. Okay, extend this a little bit. And now let's find this distance. Okay, well, this distance from here to here is the same thing. But only now we're going to work with the y's because it's in vertical direction. So this is y2 minus y1 from here to here. Okay? So this is y2 minus y1, the quantity squared. So there is your distance formula in its generic form. Okay, the way you do it is you take the square root and you find the difference between the x coordinates and you square that difference, which means it'll always be positive. You find the difference between the y coordinates and you square that difference, which means it'll always be positive. You add those two up, you take the square root, and you have the distance between the 2 points.